Now in the next problem, we have defined x to be equal to tan of b minus c by 2 into tan of a by 2 and so on. We have defined y and z as tan of c minus a by 2 into tan of b by 2 and tan of a minus b by 2 into tan of c by 2 respectively. And we need to show that x plus y plus z equals minus xyz. Now in a triangle, we know that tan of b minus c by 2 equals b minus c upon b plus c into cot of a by 2. This is the general result. Bringing this tan cot of a by 2 to the left hand side, we get tan of b minus c by 2 into tan of a by 2 equals b minus c upon b plus c, and this is equal to x. Similarly, we can get y as a minus c, or rather c minus a upon c plus a, and z as a minus b upon a plus b. Now b plus c upon b minus c equals 1 upon x. Applying componendo dividendo, on this we get b upon c equals 1 plus x upon 1 minus x. This is the first equation. Similarly, applying componendo dividendo on this term, we will get c plus a on c plus a upon c minus a equals 1 upon y. We will get c upon a equals 1 plus y upon 1 minus y. This is the second equation. And similarly, a upon b equals 1 plus z upon 1 minus z. This is the third equation. Now multiplying the first, second and the third equations, we get b by c into c by a into a by b equals 1 plus x upon 1 minus x into 1 plus y upon 1 minus y into 1 plus z upon 1 minus z. This all gets cancelled out and we get 1, and when we cross multiply we get 1 minus x into 1 minus y into 1 minus z equals 1 plus x, 1 plus y, 1 plus z. This becomes 1 minus sigma x minus sigma xy minus xyz equals 1 plus sigma x plus sigma xy plus xyz. This 1 gets cancelled out. Similarly, sigma xy terms gets cancelled out. So we get minus sigma x minus xyz equals sigma x plus xyz. Hence 2 sigma x equals minus 2 xyz. Hence x plus y plus z equals minus xyz. And this was the relation we needed to prove.